Okay, we are going to be doing a quick review of Chapter 1. If you remember Chapter 1, we looked at the equation y equals AF B x minus C plus D. Those may not have been exactly the letters that we used at the time, but that's what we're going to be looking at today. The other version that this was sometimes in was 1 over a y minus d equals f of b x minus c. So we had version 1, version 2. We will be concentrating on version 1. And a little glitch there, as this is the version you'll see most of all. So that's what I'll be looking at today. Okay, so first off, the role of A. That thing is annoying. Okay. Try to change pens. Okay. So we're going to look at y equals a f of x. It's f of x. This will give us a vertical compression or expansion. Okay. Conditions: it will vertically expand if the absolute value of A is greater than 1. We'll get a vertical compression if the absolute value of A is less than 1, i.e. fraction. Okay. If A was negative, rewrite that so it looks nicer. Then we got a reflection. About the x axis. Okay, so quick examples of this is, let's start with a graph that looks like this. Our parabola, it's one we tend to like to use a lot. Oh, go away. Y, so we'll just call it a general parabola. And this will turn into doing some setup here, will turn into this skinnier graph if A greater than 1. See, all the y values have increased, and will turn into a fatter graph if A is less than 1. Okay, so we'll get different points depending on the value of A. Okay. If A is negative, the graph rotates. So there's the role of A. Let's look at the role of D. Okay. So y equals f of x plus d. Okay, this was called vertical translation. And f of x went up if d was greater than 0, down d less than 0. Pretty obvious and pretty intuitive. So again, if we started with this sort of thing, and I want blue, we would end up with, let's get the graphs. D greater than 0, d less than 0. And this distance in here, I have to figure out how to get rid of that thing. This distance in here would be, oops, would be d. And this distance in here would be d down. Okay. Looking at the vertex. Remember, when we're looking at graphs and we're looking to move them around, we tend to try and find key points or certain points that we can easily track. So on a parabola, the obvious point is the vertex. But any points would work. We could say if we had the point here, its equivalent point would be there, and the distance between the two of them, it's not going to show very well on this graph, but that distance between them, there I did it again, would be d. Okay. Easier to look for good points. Okay, the harder stuff now. Harder stuff is looking at, we'll stick with red, I guess, stuff that happens to the x variable. So we'll look for horizontal translation. Now, the thing we have to remember about this is stuff goes backwards. Okay, so what I mean by that is if c is greater than 0, we move to the right. That seems to make sense. C less than 0, we're going to move to the left. Okay, now that seems pretty intuitive. The problem is the way it looks in the equation. Okay. When c less than 0, x minus c will become x minus negative c, which becomes x plus c. So our function is written like that. We move to the left. Now, one of the ways I've used to demonstrate this before is, say we're at a point A, that x equals a. Okay, move x to x minus c. So now we're at x minus c. We want to know where that point A went. So x is now at a plus c. So we can see how the minus turns into a plus when we do the algebra. This says move point A c units to the right. And similarly, if I have x plus c equals a, then x equals a minus c, and I guess I could call that x new. So this time we'll move point A c units to the left. So graphically, go away. Okay, we're going to get three things happening here. Okay, so start graph there. Let that be our start. If I move the graph to there, so there was the vertex, there's the vertex now. That will be y equals f of x minus c. C is positive. Or move it there, so the vertex is there. That's y equals f of x plus c. C is negative. Okay, not the best graphs in the world. Okay. All right, moving on. Y equals f of bx. This was a horizontal expansion. If b was a number less than 1, compression if the absolute value of b was greater than 1. And again, we can see we're kind of doing the opposite. When I have a small number, I'm going to expand it. When I have a big number, I'm going to compress it. And that again comes out of doing the algebra. If I'm at my x equals a, I go to bx. I want to know what happens to a. So a is now 1 over b times a. So if b is less than 1, then 1 over b is greater than 1, and we expand a. It gets bigger. And if b is greater than 1, then 1 over b is less than 1, and we compress a. So again, this opposite. So to illustrate this, the best one we have, not going to bother with color, is let's look at this graph, which hopefully we recognize as a sinusoidal graph. Okay, so there's our y equals f of x. If I compress it like that, y equals f of b of x. So in this case, b would be a number bigger than 1. And just a little review, if we remember that from chapter 3, period was 2 pi over b. So if b is a number bigger than 1, then this would tend to make the period smaller, which means the graph goes through more cycles in shorter amount of time. Okay, so the next graph, of course, we expanded it. Let's do that. And this is, again, y equals f of b of x, where b is less than 1. Okay, so we've or done things on the horizontal, again, that would tend to be larger. It takes more time to get through a single cycle or a period. Okay, so that takes care of the basics. One thing that should be noted, if B is negative, we get a reflection in the y-axis. Which is a hard thing to draw, so I'm not going to bother. Okay, now, something to be worried about or careful about when you're dealing with y equals f of a, b, x, oops, write this correctly, minus c plus d, and that is that this coefficient better be 1 when you're dealing with things. So if you're ever given an equation, and it's one of the great little annoying math things that math teachers will do just to trip you up, is they'll give you something like this and ask you to certain things like what's the period or what's the phase shift if we're using terminology from chapter 3 and 4. Your first job is to look at that and go, need to do something. And what you need to do is factor that out first. Not much trick we can do with the y's, but that's one of the things that we can do with the x, and we like to do it because it trips you up, so be careful of it. Okay, next little bit to do. One of the other things in chapter 1 was absolute value of a function, which you tend to do at the very end because that would be the bracket. So anything else, translations, compressions, would be done first. Then you would do an absolute value. It tends to make things easier. So treat the absolute value as brackets. Okay, so basically all you had to do was remember that anything below the x-axis rotates up, all else stays the same. Okay, so a quick little graph of what that would look like. If I had, again, we'll use our friendly parabola. There we have it. Okay, those 2 points there, so there they are. So everything up to there will stay the same, and everything below will go up there. Okay, so if that was the point, well, it couldn't be -5. If that was the point 0, -5, this would be the point 0, 5. But everything else is normal. And that's how an absolute value works. So first thing is graph the f of x. And again, do all your compressions. And translations, and then do the absolute value. Okay, last little bit that we did in chapter 1. And that is the reciprocal y equals 1 over f of x. Okay. Again, job 1, graph y equals f of x. Okay. Then certain things you have to remember. Remember that reciprocal of 1 is 1. Negative 1, negative 1. And that means if the graph goes through those points, those y values, the reciprocal will also go through those points. The other thing to remember is 1 over a big number will yield a small number, and 1 over a small number will yield a big number. And when f of x equals 0, we get vertical asymptotes, okay, which you cannot cross. Okay, so these things are do not cross. Horizontals, cross all you want. Verticals, no. So, little example of how this is going to work. I guess if I was smart, I'd use the straight drawing tool, but I'm not. Okay, so let's start off with, go away. Start off with a general graph that looks like that. Okay, now here are the points. There's what I want. There are the points where we have vertical asymptotes. Okay, up here I have big values. Okay. Down here are my small values. Okay, so what's going to happen? Look for the points that I'm approaching, these vertical asymptotes. That's what I'm approaching. So I used to be big, so now I'll be small. And as I'm moving in this direction, because that's how we read graphs, we always go left to right like we read a book. So as I'm moving in this direction, I have big values and they're getting smaller. While the reciprocal then would be, where did that line come from? Would be small values that are getting bigger. So there we go. Okay, everything's positive, so it'll remain positive. Similarly here, okay, I have big values and they're getting, or I'm starting with small. If I want to continue thinking, I'm starting with small values and I'm getting bigger and bigger and bigger. So that means start with big values and get smaller and smaller and smaller. Okay, this point is negative, so it'll stay negative, and it will move up closer to the x-axis. Okay, so if that was the point 0, 4, this would be the point 0, 1/4. Okay, I'm starting small here, getting bigger. So if I'm starting small, that must mean I'm big, and when I'm reciprocal, and I'm getting to that. Okay. Now, going back towards small, which means the reciprocal will go toward big. Okay. And there you have a reciprocal graph. Okay, you remember the 1 over bigs? and the points, if there's any ones on here, if that was the point 1, it would still be on that graph because the reciprocal of 1 is 1, so that will remain the same. Any place that y is equal to 1, the graph still goes through that point. And that is a quick and dirty review of Chapter 1. Okay, so we looked at y equals a, f, b, x minus c plus d. Vertical compression or expansion. Vertical translation. Okay, we compress a less than 1, a greater than 1, and remember we're dealing with absolute values here. Vertical translation, up, d is positive, down, d is negative. Horizontal compression, horizontal expansion. Okay, compress when we're big, expand when we're small, the opposite. And horizontal translation, to the right, c is greater than 0. So the equation will look like x minus c. To the left, c is less than 0. Equation will look like x plus c. And that was Chapter 1 in a nutshell. And I'm done. So now to turn off the recording.